Hello everyone. Good morning. Welcome to Technical Tutor. In the yesterday's class, we have started with an inheritance concept and I also explained about the types of inheritance also. There is one more point in that. For example, now I'm taking one class A. It's doing some logical operations. I'm taking one more class B, which extends and class A. Okay. Now, this class B, it is a child class of the class A. The A class is a parent class, right? The A class is a parent class and the B class is a child class of the class A, okay? And this B class is also having an one more parent class, okay? This A class is also having an one more parent class, that is an object class. Object class is a parent class of all the classes in Java, okay? But by default the Java compiler will supply the object class for the all the parent class when the programmer did not use the parent class. Okay, now for example, now this is a parent class. This parent class is also having one more parent class, that is an extends object. Okay, extends object. Object class is a parent class of all the classes in Java. If we don't write this also, the Java compiler by default it internally provide an object class, okay, when we don't define it, okay, we don't need to define that, but we internally know that the object class is a parent class of all the classes in Java. Let's write that points. Note that point. Object class is a parent class of all class in Java. Okay, object class is a parent class of all the class in Java. By default, Java compiler will supply the object class as a parent class. It supply a object class as a parent class for all the classes when the programmer did not use any parent class. The object class is a parent class of all the classes in Java. Okay, this is one more point we left out in yesterday's class. Okay, till here we are end with an interface concept, sorry, inheritance concept, and the fourth pillar of a OOPS is a polymorphism. Let's go for the polymorphism. Okay. The polymorphism means a method appear with the same name but behaves differently, and method appear with the same name but behaves differently is called as a polymorphism. A method which appears with the same name but behaves differently is called as a polymorphism. Let's see what types of polymorphism. There are two types of polymorphism. The first one is a static or a compile time polymorphism. Compile time polymorphism. For example, for this is an method overloading. When we are studying in third year or fourth year of your BE, on that time you will be knowing what is method overloading and method overriding also, right? The second one is a dynamic polymorphism, dynamic or a runtime polymorphism. Example for this is a method overriding. Okay, there are two types of polymorphisms. That is a static and then dynamic polymorphism. Polymorphism in static we having a method overloading, and dynamic we have a method overriding, right? Well, let's see the first one, that is a method overloading. The first one is a method overloading. Having a same method name with different signature is called as a method overloading. Having same method name, having same method name with different signature. Okay. Having the same method name with different signature is called as a method overloading. Let's see one example. I'm taking one class, sample class. I'm going to take one class. The class I'm going to take as an earth class, arithmetic. I'm taking as an earth. Taking one method, public. I'm taking an return type as a primitive, is an int type. And so I'm taking it two parameters inside it. So it's written a plus, that it's written a plus b. I'm going to take one more method inside that, public int and int a comma int b comma. I'm taking it three parameters. Okay, it returned a plus b plus c. Okay, take one more parameter, one more method, public void and print no values. See here, I'm taking in three methods. I have taken in three methods. Both of the three methods is having a same method name, right? Both of the three methods is having a same method name. The definition says that having a same method name with different signature. See here, the three of the methods is having a same method name, add, having a same method name, but they're having a different signature. That means within the parameters, they're having a different things, right? Here I taken in two parameters. Here I taken in three parameters. Within this parenthesis, there is no arguments, okay? There is no argument, but here no arguments, here two arguments, here and three arguments. That means a different signature, but the same name. This is only is called as a method overloading. Okay, this is only is called as a method overloading. Having a same method name, but with different signature. Here is no signature, that means no arguments. Here is there is an argument with two parameters. Here is also having an argument with three parameters, 2 3 and 0 parameters, right? This is only a method overloading. Okay, having a same method name but with different signature. Let's access the data. Let me create an object for that class. A dot add with no arguments and print a dot add with two arguments. I'm taking it off. I'm taking 1 comma 2. I'm going to print it down as a dot add of for an three arguments. I'm taking it as 3 comma 4 comma 5. For a dot add means I'm going for here a dot add. There is no arguments. I'm going to print out output as I'm going to get as a no values. For an two arguments, I'm going to get an for this one a plus b. That means 2 plus 1 is a 3. For this thing, I'm going to get an output as a 12. For 3 plus 4 plus 5. This is only about a method overloading. Okay, method overloading, having a same method name. See, I'm having a same method name, right? Add. The method name is same, but they're having different signature. The first one is having two arguments, but the second add is having three arguments, but the third add is having no argument. But that means different signatures, right? But the same name. This is only is called as a method overloading. I'm going to return same output. See now. See no values 3 12. This is one example for a method overloading. Let's see a method overloading on the inheritance. Okay, how we are going to use a method overloading on inheritance. I'm going to take in one class, class A, with some method public void m with no arguments, printing as an A class. Within the child class I'm taking it B class, extend the features of A class. Now I'm going to print, sorry, within the B class I'm going to take in one more method, same method name but with different signature. I'm taking as an int as an arguments, integer arguments. Okay, I'm going to print it on as a B class. Within the same class I'm going to take in one more method, public void yum, and some string arguments, string s, print it on as a no class. Okay, print it on as a no class. See, in the inheritance concept also, see, in the parent class I'm taking the same method name which is there in the child class also, same method name, yum. The method name is same but the signature is different, right? In the parent class I'm taking a no signature, that means a no arguments, but in the child class I've taken a two method with a different argument with a different signature. For first one I'm taking as an integer and the second one I'm taking as a string arguments, right? For second one I'm taking as a string arguments. It is also overloading is also working on the inheritance concept also. Let's access the data. Create an object. In the inheritance, we are going to create an object for a child class, right? New b dot yum with no arguments, and next p dot m with some int arguments. I'm taking integer value as 1. P dot m with some string argument. I'm taking a string value as a Java. Okay. Without arguments means this one. Without argument means for the first parent class that I'm going to get output as an A class. Okay. For an integer argument means I'm going to get an output as a B class. Here is an integer argument. Here is an integer argument. Here is a string argument. String argument means I'm going to get an output as a no class. Right. These are the outputs we are going to get it done. Let's see the output. C A class, B class, and no class. This is how we are going to use and method overloading concept or inheritance concept also. We can have this overloading concept on inheritance, or normally also we can use it on also in the inheritance concepts also. Okay. The same method name but with different signature. The same method name in the previous example also the same method name, right? Add same method name but different signature. Here also same method name, same here also same method name, but there is no arguments with the integer argument and string argument with different signature. This is only called as a method overloading. The second one is a method overriding. The second one is a method overriding. The second one is a method overriding. Method overriding means changing the behavior of the parent class from the child class. Okay. Changing the behavior of parent class method. This is parent class or an instance class, right? Instance method. Parent class method or an instance method from child class. But see, the overloading method overloading concept we are done for normal classes also, we are used it for an inheritance concept also, but this method overriding is applicable only for an inheritance. Okay, it is applicable only through the inheritance. Okay, the method overriding is applicable only through the inheritance. I'll add that point also. It is applicable through inheritance only. It is applicable through inheritance only. Let's see some condition is there. To the conditions. The first condition says that it should have a same method name. Both parent class and a child class both should have a same method name. Okay. Both should have a same method name. And the next point is that both should have a same parameters. Okay. Both should have a same parameters, but type or order also. Type or order should be also same. The third point says that both should have a same access modifier. And the fourth point is both should have a same return type. Both child class in the child class and a parent, that overloading is applicable only for inheritance means there will be a parent class and child class will be there definitely. And both the parent class and the child class should satisfy these conditions. Okay, both of them should satisfy these conditions applicable for both parent and child class. It is applicable for both parent and child class. Okay, both the parent and child class should have a same access modifier, same return type, same method name, and same parameters. Let's see one example based on that. I'm taking one class with a test class, the main method. I'm going to take one class as a shape. Okay, I'm taking one method within that class, public int area, with two parameters. I'm taking int a comma int b. It return a into b, area of the shape. Now let me take one more class because this overloading is applicable for inheritance means we are going to take one more class, a child class. Triangle extends shape. Okay. See, there are some conditions in the method overriding, that is it should have a same access modifier. The access modifier is in public. I'm taking here also in public, and that it should have same return type, int return type. I'm going to take same return type. There should be an same method name. I'm taking same method name, and it should have a same parameters also. Okay, it should have same parameters also, but it should behavior will be changed. Okay, changing the behavior of parent class methods from the child class directly. So but it's doing an action as a different x plus y divided by 2. Now let's create an object for an triangle, that is a child class. Triangle. Okay, let's print it down. Print t dot area of, I'm taking t 10 comma 50. Taking 10 comma 50. So if I'm going to print it down means I'm going to get an output as an 30 because it's going here, it will print here only, but it's not accessing this data. For that I'm going to use a super dot within the print statement. Print super dot area of int a comma b, that is in 10 comma 50. Okay. See, the method overriding means changing the behavior of the parent class methods. Changing the behavior of the parent class methods from the child class directly. Okay. You are here. We are going to change the behavior. Here we are going to do an operation as an a into b, but here we are going to do an, we can take and same parameters also. Okay. Let's see, by taking same parameters, that means and variables names also. Let's see the output. See, I got an output the correct way only. That means in changing the behavior of a parent class method from the child class directly. We are changing the behavior of the parent class. Here the parent class is doing an operation a into b. But here you're going to do an a plus b by 2. Okay. And we have a condition in the overriding, that is it should have a same access modifier, same return type, same method name, and the same parameters also. Everything is satisfying, right? Everything is satisfied, but there is a return type we are going to do an operation is different. You are going to do a multiplication, you're doing some multiplication with addition with division operation, right? This is how we are going to do on an overriding concept. Okay, this is one example for an overriding concept. You can do some more examples, you can practice some more example on this also. Okay, I'm going to end here. Today I'm done with an uh, polymorphism also, two types of polymorphism, method overloading and method overriding. Method overloading is applicable for both on the normal class also in the inheritance also, but method overriding is applicable only through the inheritance only. Okay, I'm going to end here, guys. Thank you.